So general like general information. This meet would be recorded. So if you don't feel okay being recorded, then like it would be better than you cannot. If you don't want to turn on camera and don't want to be part of the recording, then it's fine. If you have any questions or anything like that, you can use chats or you can unmute and speak up when the speaker says so. Uh, don't interject when someone is talking. And yeah, that's in general. That's it. Uh, Ankush, let us know when we start. Okay, I guess we are good then. Hello everyone, I am Darshan. I would be the host today. Uh, I have little to no experience in hosting such online events, so bear with me. Apart from that, uh, I I am what organizer at OTC with Harsh. Um we OTC talking about OTC a bit. OTC is a small community we started during our college, and we have been doing like catch ups every week since what 2 3 years. Yeah, so this is what two. Wait, I don't remember the years numbers at this point, right? So it has been a long time since we are doing this. So we started talks because we wanted to give direction to the catch up and also bring in more knowledge. So if you are interested to talk about anything, feel free to drop in your suggestions or things that you can talk about. So I'll just share a link here for CFP. If you want, we welcome you to fill up this, and we'll surely contact you if we find your topic interesting, and we can schedule one talk for you. So talks, OTC talks, we try to keep it once a month, mostly to the third or fourth week of the month. So yeah, that's about talks. Let me introduce Harsh Kapadia. He was our senior. Again, he is also an organizer at OTC. Uh, he he works. uh, Apart from that, yeah. So Harsh has a tendency to go deep into a topic and talk about it. He is very enthusiastic about those topics. We understand that, but Harsh, please control yourself. We have an hour. Okay, so let's not stretch it. Okay,
Yes.
so keeping giving it to Harsh. Harsh, all yours.
Yes. Okay. Thank you so much, Darshan. Appreciate it. Can you see my screen? Question of the century.
Yep,
Yes. Okay.
we can.
Okay. So, what we'll be talking about today is implementing high availability for MAAS-based automated OS installs. The focus of this talk is to showcase a simple example of high availability. MAAS is just an example that will be used to showcase how high availability can be implemented. So I want to show a simple use case of high availability, and MAAS is just an example to showcase that simple use, but you don't need to understand what MAAS is, or when I introduce it, you don't need to know much about it. We will mainly be talking about high availability, and that's the focus of this talk. Okay. So we'll be talking. I'll give a short introduction to high availability and a shorter introduction to MAAS. Then we'll talk about a sample architecture that can be used. There are multiple possible architectures, but this is just one example. And then the meat of the talk will be the implementation side of things on how the use case that I want to sort of present, how does that work, and how one can think about it, how it handles failures, and things like that. So that's the high level agenda for today. Okay, so what is high availability? So high availability refers to a system's ability to be operational, accessible, and responsive and resilient to failures almost 100% of the time. So it should be highly available, essentially, as the name says. So it should be able to tolerate a certain degree of failure. So it's not that if everything goes down, obviously the entire system will go down. But if there are one or two failures in one or two components, the system should still be able to handle that and function normally, so that users don't get impacted and we can minimize downtime. And while we are working to fix the components that are not working very well or are just degraded or are down, the automatic failover system and other things are still handling the system, and there's no impact for the users, right? System looks functions normally for the user, right? That's essentially the experience that we want to create for the user of that system, that, oh, everything is fine, there's nothing wrong. But on the back end, when things are wrong, we are working to fix the issue, but the automatic failovers and things like that have already taken are still running, so we are not having a downtime, right? So that's essentially what we are trying to do with high availability. So as I mentioned, the need for implementing HA is you want to eliminate single point of failures. For example, if you have one database instance, for example, and that goes down, so your entire website goes down, right? If it can't retrieve data or add any data to the database, your website is essentially down, right? So that is a single point of failure. So we want to add backups there. Hey, if one database goes down, the second copy of it automatically takes over, and the website user experiences no failures or anything like that, and it's all okay for the user, right? So we want to eliminate that single point of failure using HA. And the second thing is critical services should not go down, right, to minimize downtime. So for example, DNS is an example, right? So if suppose a system is managing DNS for you, and that system goes down, if that goes down, well, you are not going to be able to reach your systems, right? You're not going to be able to reach websites if the DNS server is down, right? So any critical service that you have should have backups and should have automatic failovers, so that you're able to minimize downtime and keep going, and user experience is not affected while you're working to fix the issue, right? So that is essentially why you need high availability. The two major things that you're going to hear throughout this talk is high automated failovers and automated backups. That's mainly the use case that I wanted to focus on and show. So yeah, that's what we'll do through this talk. Now, before we get into the use case that I want, the high availability use case that I want to show, I'm going to use MAAS as an example for that. But again, you don't need to know MAAS before, or you don't need to understand it very well to understand HA. So this is just a short intro so that you have some context. But again, you don't need to understand this very well. That's completely fine. Okay, so MAAS is Metal as a Service. It's by Canonical. Canonical, if it doesn't ring a bell, is the company behind Ubuntu. So Metal as a Service MAAS is an open source product. You all can go and try it out. It's on GitHub. And it provides a centralized way of managing and provisioning and deploying servers. It can do thousands of servers and manage the entire life cycle of a server, right from deploying an OS and releasing the OS and multiple other testing the OS, and it can do testing the server and can do multiple things, right? So essentially deploy and manage the life cycle of thousands of servers from the start of the deployment process to testing the server, to finally, once work is done, to release the server and get it back into um, available, like a ready state, right? So someone else can use it. So if you look at the picture on the right, can you see my mouse now? I have to enable the pointer, I think. Pointer. Can you see this? Okay, good. So if you look at the picture on the right, this is a simple basic example of what MAAS kind of does. It will discover the server that you have on your network. It will first figure out and then it will figure out what the server has, what RAM, CPU, disk, what network cards does it have. Then it will essentially, once you say, okay, deploy a particular OS on that server for me, it will do the deployment for you, and you can do any of your work, and then you can once you're done with your work, it will release the server for you, and it is again back in commissioning state so that you can redeploy and do whatever work. So this cycle keeps going on, right? So MAAS makes this easy where, because it has an API through which you can interact with it, so you can just tell it to do things, deploy things via an API call, and that makes things very fast. Um, so that is high level overview. So the main part that we will need for this talk from MAAS is just its basic structure. Again, you don't need to understand what it's doing and things like that. Just know that there is a basic structure and what it is. So MAAS mainly uses two main servers or systems to control all its servers. Um, and that's the region controller and the rack controller. So region controller is the main brain, and rack controllers are do some smaller tasks, right? Okay, so the region controllers controls services like your database, which has all the details of your servers, and well, it's a database, right? So you store a lot of information in it. Then it also manages DNS, so all the servers that it deploys and things like that, it manages the DNS for the server. So users, when they want to reach particular systems, they essentially MAAS will provide the DNS record for it, right? That's how the user is able to access that system. So, so again, we can see that the DNS server is very important, right? That service is very important. Then there's an API server through which you send commands to MAAS. Again, extremely important because the entire point is to make things faster and quicker. So API server is important. And there are a bunch of other things like DHCP, TFTP, HTTP for managing OS images and power management, things like that we don't really need to talk about. So the main things are database, right? So it has database to store server information and system information and DNS records and different information, right? Then obviously it has its own DNS server. So DNS record information, any DNS information is stored, right, within MAAS. So that's important. And then obviously the API is also very important so that you're able to command MAAS and reach MAAS, right? So this is like a short intro about MAAS. You don't need to understand it completely. Just know that it has these three services which are very critical, right? If DNS goes down, users can't reach systems, right? That's bad. If your database goes down, the entire system is useless because it can't figure out which system is where, and it doesn't have any data essentially. So database is very critical. Then API. If the API is down, MAAS is running and there is a system running, but nobody can reach it. What's the point of the system, right? So that's why these are like critical things that you need to focus on. So that's essentially why I used MAAS as an example, right? So the yes, Tushar?
Just a quick question on the previous slide.
Yeah.
Oh, is there a reason why these texts are color coded? Like DNS is separate, DB is separate.
Yes, there is a reason. It'll come up in the next slide. Yes.
Okay, got it.
It's essentially telling you clusters, right? So database is going to be one cluster that you manage by yourself, then manage by itself. Sorry, and DNS is another thing that you manage by itself, and everything else is sort of clubbed together, kind of, right?
Okay.
So you'll understand that in the next image. But yeah, okay. So now that we have a short understanding about MAAS, what we need is this, right? What is the architecture? So again, this is one sample. There are many other ways to do this. This is just something that I wanted to talk about because I found it interesting, right? So again, and don't worry, I'll explain WIP and all of these things and all these technologies and everything. So just a basic structure is these are the brains, the controllers that MAAS has. This is the brain of the system, right? They are in one cluster with each other. Then DNS is consisting of three, if you can see with three, right? That DNS cluster is consisting of three nodes in itself, the two controllers and a DNS only solo backup node as well. And there's a third cluster, which is the database cluster, which consists of three nodes in itself, right? So there are three main clusters here, and we'll talk about each one of them, with database being the most interesting one. And the meat of the talk is essentially going to be about implementing HA for the database, right? That is the main focus of today. Okay, so yeah, so there's 3 clusters: VIP1, VIP2, VIP3. This is for just for MAAS services. This is for DNS. VIP3 is for DNS, which consists of these 3 nodes, and there is a database cluster. So this is it, and we will talk about the details of each one. Okay, so as I mentioned before, 3 clusters, so sorry, I mentioned that there will be 2 main themes. It would be automated failovers and automated backups. So for failovers, there's database high availability, DNS, and MAAS, and database backups and OS images. We'll talk about each one of these things in upcoming slides. I just wanted to give an overview of what is coming, right? So we'll spend most time on the database stuff. Everything else is going to be fairly quick. Okay, let's get started with the database stuff. Okay, so I know this slide is dense. Just bear with me. We will break it down. It'll become easier with further slides. There are a few pictures which will make it apparent on what's going on. But okay, so what are we using here? We're using Postgres, Patroni, HCD or etcd, HCD, whatever you want to call it, HA proxy, which is a load balancer, and using KeepAliveD. Okay, first off, let's talk about Patroni, right? So we're using PostgreSQL, right? We're using Postgres as a database. So Patroni is something that manages a Postgres cluster. There are multiple types of ways it can do this management of this cluster. So what it essentially does is, if you have, for example, in this case, we have these 3 database nodes, right? So one is primary and 2 are secondary. So what it can do is the service talks to just one database, while the other 2 are secondary. So when the service is talking to this, storing data from and writing data to this, what Patroni will make sure is that these other 2 will also get that data from the primary, and so this will have it'll essentially keep these secondaries will keep following the primary and have data updated. Right. The way in which this data can be updated, there are different types. One of the type is synchronous replication. The other type is asynchronous replication, where synchronous is okay. So when a request comes in, you write. When a database write comes in, you write. Wait for all the other nodes to tell you that okay, we have also written that, and then you carry forward. And asynchronous is obviously asynchronous. So the write can happen, and when the secondaries update is not fixed, it can just happen whenever. And there is also another type which I'll not talk about, which is it can be streaming replication or log-based replication as well, where it can where changes can happen real time in streaming, or it can be a log-based where it sends chunks of updates. So let me synchronous, asynchronous, streaming, and log-based. So there are multiple types. Synchronous replication, synchronous is the easiest or the most standard one, at least for a simple deployment. So this is a 3-node cluster, and the way Patroni handles things is if one of the out of the 3, one goes down, then all good. It can still support read and write. It'll automatically promote one of them. So if DB1 goes down, it'll automatically promote DB2 to secondary, and DB3 will still be DB2 to primary, and DB3 will still be secondary, and this will function normally, no issues at all. But if 2 go down, so 2 database nodes go down, then the third one will only function in a read-only state. There will be no writes allowed. So that's how Patroni does things. And Patroni also has some configuration that it has to apply to each of these 3 database nodes, and that it doesn't do itself. It relies on a third-party application to act as a configuration store, which is a fancy term is distributed consensus store, right? So some of the options are HCD, Zookeeper, Kubernetes, etc. Right? But HCD is what is used, can be used as well. And yeah, it is used to store and apply common configuration across the cluster. Um, so then the third thing is HA proxy. Now, why a load balancer? HA proxy is a load balancer, by the way, and why it's required and stuff is something we will see in further slides. So for now, just bear with me, just understand what each thing is doing, and then we can get into its function and stuff like that. Or sorry, yeah, get into stuff like that in the next slide. So yeah, so HA proxy is a load balancer, and it is essentially figuring out which is the primary database in the cluster by asking Patroni, hey Patroni, Patroni has an API, right? So HAProxy will ping Patroni's API and be like, hey, who's the primary right now? Please give me DB1, DB2, DB3. Which of the three is the primary? Please tell me which one it is. So that it can route that request to the current primary, right? So that's the load balancer. It will route queries coming from the user to the primary database in the cluster, primary database node in the cluster. Yeah. Then you have keep alive D, which is essentially here is where we get into something that was very new for me, which is virtual IP addresses, right? VIP. So a virtual IP address is essentially so what we want is in these three nodes, we don't care who, so the service doesn't care who, or the user doesn't care which one is the primary, right? It just needs one IP address where it can send the database read write request, right? It doesn't care who is answering that, which of these three nodes is answering that request, right? Read or write request, right? So we need one IP address. No matter which database node is answering, we need one IP address, right? So virtual IP address is the way to do it, where there is one IP address for this particular cluster. There is only one IP address, and keep alive D is something that helps you maintain this virtual IP address, where it will check in these three nodes. Okay, based on a health check and a priority, I'll get into that. Based on some health check parameter, it will figure out, okay, who's the current primary and who's alive right now, and I will and that particular node will own the IP address. In case there's an issue, it will automatically detect that issue, and some other node will own the IP address, right? So it's an IP address that keeps floating between different nodes based on certain priorities and certain health checks that you set up, right? So that is a virtual IP address where it's not belonging to it doesn't permanently belong to sort of one node. It can switch nodes based on certain parameters. So yeah, so that is why you need keep alive D, because the user wants one IP address. It doesn't care which node is answering you. So keep alive D is something that is a software that helps you maintain a virtual IP address, and it uses a health check and a priority. And we'll see examples of that in upcoming slides on how it switches. And so it uses a combination of health check and priority to assign the VIP to a node. And yeah, now let's sort of get into scenarios, right? So everything is working fine. The user, which is MAAS in this case, just an example, it can be anyone, right? It can be a web app, it can be anything. So so this is the best case scenario, right? We have keep alive D, we have HA proxy, we have database one, we have Patroni one, etc. one, right? So, and this is there in three nodes, right? We have DB1, DB2, DB3. These are those three nodes right here in front of you, right? So now, for example, we have keep alive D has priorities 40, 50, and 60, right? Higher the priority, that is the that node has the priority, right? So 60 is the highest number here. So it owns the VIP. So when MAAS pings an IP address, it will automatically get to here because this one owns it, right? And yeah, and then there's HA proxy, which keep alive will ask for to route the request, right? So what keep alive D's function is, okay, I got a database read or write request from my user, and keep alive D it maintains the IP address. Okay, so the request got to this particular node 2, right? So the request got to node 2, but now where does the request go, right? So the request has to go to the primary database, right? How do we figure that out? right? So HA proxy is the brain that sort of helps us route the request to the correct place, right? So HA proxy will ask Patroni, it will ping Patroni's API and be like, hey, please tell me which is the primary right now. And once Patroni tells it, it will route it to that correct node internally, right? So that is the best case scenario uh, um, case of routing a request, right? So any questions around this? The best case, we'll get into when things go wrong and stuff like that. Each component we sort of mess around with and figure out how it works. I Is that a question? Or are you just making a point, right? And yeah, Pratik, what's up?
No, those are some points, some questions.
Okay. The sync between PG replicas are handled by PG itself. Okay. I did not know that. I thought Patroni handles that. But okay. Is HA proxy performing full at X time interval for is primary? If so, what is the interval? Again, the interval can be whatever you set it to, and yes, it keeps pinging Patroni for that. And the way it detects it that it's down is that it'll. I mean, there are multiple ways to do this. One of the ways that at least I know of is that you can keep asking if it fails for 3 times, you can declare that if the API call to Patroni fails 3 times, you can declare that the node is down or things like that, right? You can configure things like that. Okay, if my request fails 3 times, I'm going, after whatever interval you set, I'm going to declare that this node is down, and that means the database is down, right? So there's multiple ways to check that. This is one way to check.
One question. When you talk with for is primary, you do it with Patroni, right? You hit Patroni's API to ask it. Okay. And it does not have a subscriber model for this, where you can subscribe to it for a change.
I don't think HA proxy works that way. I think, but again, I'm not an expert on this. So again, yeah, if there is a subscriber model, I don't know about it. So yeah, what HA proxy is doing is just constantly asking Patroni after a certain interval, hey, who's primary, right? So yeah.
Got it.
So that it knows.
Yeah. And the last one.
Once you have a load balancer, you already abstracted the database cluster. So won't the VIP's actual use case be in case of HA proxy failure? You can go. No, you have to explain that to me.
Sorry. I might have. Okay, fine. So you said that the VIP, the virtual IP, by Keep Alive was to abstract the IPs of the database cluster. But haven't you already abstracted that by HA proxy? So the real use case here for the virtual IP would be that in case of a failure at HA proxy, you just simply have to worry about spinning up HA proxy again and not worry about the clients of HA proxy, in this case MAAS. Like configuring MAAS again with a different.
No, adding a load balancer did not just abstract it away, right? I still need one IP address. There are 3 load balancers, right? Each node has its own load balancer, right? So how does the user know which load balancer to hit?
Okay. So again, the IP, basically the IP is a abstraction over the IP of HA proxy rather than the DB cluster, right? The DB cluster is moved by this point because it's abstracted one layer behind the proxy.
Yeah. Okay. Yes.
Right. So the VIP use case is for HA proxy and not for DB. Am I correct?
Sure. How you look, it depends on how you look at it. Yes.
Okay. Fine. Cool. That's it.
Okay. Fair. Karthik, yes.
Sorry, can you? So, from what can you explain why HA proxy 2 is talking to the node 1?
Because currently it is the primary, right? So database 1 is the database 1 is primary, right? So it has to route the request there, right?
Yes, no. Okay, so why does every node have a proxy?
Um, Hold on.
Generally, the pattern
So
that I have
what?
seen is you have your database clusters, and then there is a proxy, like a load balancer in front of them, and that proxy then routes your query to the active node.
Yes, but
Yeah. So
sorry, Harsh, go on.
yeah, but in this case, you if I have only one HA proxy which is out into all three, what if that HA proxy goes down, right? So then that also that again becomes a single point, right, of failure.
Yes, but then that is still. I mean, then you would create again a. You'd either have a cluster or something else, but then I because I if one node goes down,
Mm-hmm.
then you are losing the proxy and the DB.
Yeah, but it doesn't matter, right? I mean, someone else will take over, right?
No, okay. So why do you have keep alive and HA proxy?
So how would you want it? How would you want it to be?
No, no. Again, uh, I have not. I've never used keep alive, so I'm not sure what it does exactly. But
One question
Yeah.
with this only, with this in mind. At the same, basically, me and Karthik are confused with the same thing. Does keep alive synchronize between all three nodes? Keep alive one, keep alive two. Does it have the same VIP?
So there's only one owner at one time. So the VIP is owned by one node at one time.
But
But
if that
if this
fails,
node goes down, keep
yeah,
alive D is talking. These three nodes are talking between each other. These three keep alive D things are constantly talking between each other, right? So if one of them goes down, keep alive D figures that out, and whoever has the higher priority takes up
got it.
that VIP.
And it's basically the same IP, right? Since
Yeah,
that's
yeah,
why
it's the same
only
IP, one
one
IP
can get it
address.
at one time. Got it.
So
Yeah.
yes, Alex. So I understand that having multiple HA proxy nodes is you don't want a single point of failure. I am not very sure about coupling it to the database because now again you are essentially hmm, because
This is a hyper-converged setup. So you have three nodes. However, you're running multiple services on top of a given node. So you have your database cluster, your HA proxy, and keep alive the also the MAAS services, across distributed across these three nodes. Traditionally, you have like separate, nodes running different components, but this setup is like more efficient, especially if you're leveraging physical nodes and have plenty of resources. This is a better use of resources. I believe that's the reason, partially, right?
but then why do you have the keep alive like the highest priority node is not the one that has a primary DB cluster? Like, why are you jumping across nodes? Um, or is
yeah,
it
that can
just
be an improvement that we look at the priority dynamically. So KeepLiveD does have a dynamic way of setting priority, but yeah, so that can be an improvement on this thing for sure, right? That you figure out which one is the primary database, and KeepLiveD also figures its priority based on that, so you don't have to talk across nodes. Fair enough.
right? So I see, I see,
So this
and
example is just showing like static priorities, but KeepLiveD can have dynamic priorities as well.
and when you say virtual IP, what is handling the resolution of that IP, or
I
the
am not. I don't know the internals of KeepLiveD. I just know that it uses a protocol called VRRP, Virtual Router Redundancy Protocol. But again, I'm not aware of the internals, so don't take my word for it.
I see, and does it have any checks to ensure there are no duplicate IPs? Because I presume this is each node has a primary IP and then the floating IP. And then
Yes.
are there any checks to because each node will then
Does that
dynamically
internally?
Okay, so keep alive is
It
only
handles-
used for the IP sharing,
Yes. Yes.
and then HA proxy is used for the actual proxy routing.
Yes.
I see. And how are you handling the? There's no firewall on this or something, or just
No. No.
everything is like directly accessible.
Yes. Yeah.
So HA proxy directly connects to the DB on that port.
Yeah.
I see. Okay.
Yep. So now, yeah. So now what we can do is start taking services down and see how the system responds, right? So first, let's start with taking either keep alive D down or HA proxy, either one, because keep alive D is constantly checking if HA proxy is up as well. If HA proxy goes down, keep alive D will also panic, right, and change. So either HA proxy goes down or keep alive D goes down, same thing's going to happen. So okay, so if either goes down, for example, let's say HA proxy 2 goes down for some reason, what will happen is a keep alive D here, which is checking for a health check, check on HA proxy, that will fail. So keep alive D will say, hey, even though I have the highest priority, I'm going to panic and talk to the other nodes, and whoever has the highest priority will become the owner. This is the case if HA proxy 2 goes down. Now, if keep alive D, HA proxy 2 is up, but keep alive D 2 goes down, then again, because these three keep alive D nodes softwares are talking to each other, so they know, right? So they have their own internal talking. So if someone doesn't respond, then they again be like, okay, so that has to be cut off, and the WIP has to be switched over. So that is, I think that answers Wilfred's question. So yeah, so in that case, keep alive D 3 who's up takes over, HA proxy 3 is up, and that routes the request to the primary node, right? So that is that is this scenario. Now let's go back to our best case, just as a reminder, right? And now let's take down the database, right? So HA proxy and keep alive D are fine, and for some reason database goes down, right? In this case, Patroni will automatically say, hey, I promoted the database. So this database is now the primary. So and as if you remember in a 3-node cluster, if one goes down, you can still do reads and writes. So database 2 becomes the primary, and things are still fine and dandy for the user. So that's the database going down. Now DB1 is offline, but let's say HA proxy 2 and keep alive D2 also go down. So again, no effect on the system. It'll just keep alive D will switch over the WIP, and things will go on, right? So yeah, this is kind of an example of a system that you can create. And any questions around this? Split brain is handled by keep alive D itself. I understand what you're saying, but it's handled by keep alive D. So Patroni has its own split brain. It's called what is it? Cut off the head node or something like this. There's a term, something that Patroni uses. So it has that as well. So
node in the
Patroni,
head.
Sorry, what?
Shoot the node in the head.
Shoot the node. Yeah, stone it. Yes, shoot the node in the head. Yes.
That is a
yeah,
PG then, actually. You can go to its documentation and it's written there.
Oh, that's PG, right? I've been reading Patroni and PG together, so it blurs over. Yeah. So
Sorry, no, but split brain is usually like. So my question is network failure not modeled in, or is that not a concern?
Elaborate, like what do you mean
failure
network failure?
So
how would that change things?
So, okay, so for example, because HA proxy and DB they are not really linked together on the same node. So what can happen is if you have one node that is the primary, if the network fails to that node, and then it has no way of communicating with the others about what has happened. The others also can communicate to it. So the clients connected to it still think that they are connected to the primary.
But how are they connected to it, Karthik? Because the whip will have moved, right?
No. So again, so the node cannot change its own. Like it does not know about its, or is there a heartbeat or something?
Between what?
Sorry, no. I mean, okay. So
Why don't you take an example in this example and sort of try to explain your point that way?
okay, so let's say the network. I presume that the node is connected to MAAS from a different network, um, as as it's connected to it itself, or is that the same network?
No, it's in the same network. Everything is in the same subnet.
It's subnet, yes, but the connection to MAAS, I believe, is over the internet, whereas the
Yes.
rest will be over a direct line.
Yeah, these. Yeah. I mean, what? What does that mean?
As in, there'll be a separate local network for nodes, right? Or
No, it's like these are all management nodes, and all of these are can be in one subnet. Yes.
yes, but okay. So my point being, let's say you have clients connected to Keep Alive D3, which is then in turn to HA Proxy 3 and then DB2. Now, if you have a network failure between, say, node 2 and node 3, but not to MAAS, then so that's why I don't know if that is possible, or that is something that you've considered, or is that not part of, that's beyond the scope of this implementation. But if you do that, if that happens, then HA Proxy 3 will reroute, but then the node 2 does not know it is not the primary yet. So it will still try to process transactions or whatever, and then later on when the cluster heals, then you might run into issues.
Yeah. Now, yeah, you have to handle your recovery properly in that case, but at least clients won't be affected initially. Like while the issue is going on and things like that, client won't be affected. And usually, and I mean, it again, there's a lot of depends here. But if your database is really small, you can just destroy the database and get it back up, like restore it from a backup, which is another thing that I'm going to talk about. Just use pgdump and you just restore it back to whatever known state is, and then Patroni, whatever is missing on top, Patroni will automatically add that from the other database, right? So that can be one possible restoration in case what you're saying happens, right? And if there's split bin and you can take down node 2 manually and delete the entire database, depending on the size, obviously. If it's small, you can do that and just restore it from the previous node backup. And then once everything is up, let Patroni itself handle the tell Postgres to handle the replication.
Okay, and last question: does it have any intelligence built in, or for cascading failure, or no?
What does that mean? What is a cascading failure? Can you illustrate it here?
So let's say there are 10,000 requests a second suddenly to the service. First DB goes down, second DB goes down. Will it then route to the third DB, or does it have enough understanding to say, this is not something I can handle? Let me not crash everything. Let me wait for some time for this to go, because, this is not built.
So initially, when I was talking about Patroni, is that there are with a 3-node cluster, if one goes down, you can still have a normal functioning. But if if two go down, then the third one is read only. That's the only intelligence that it has from at least what I know that can be configured. But obviously, there's probably much more than what I know.
Yes, no, but that is on the database side, right? On the HA proxy, can it handle 10,000 connections or 100,000 connections or whatever? So basically, if there's a huge surge in requests and it knows that it cannot handle the load, will it still keep trying until everything has crashed, or will it back
I
off
have not tested.
exponentially or something.
I have not stress tested HA proxy, but I don't know what the default behavior is either, to be honest with you. So yeah.
Because a lot of services, especially now, so
Mhm.
one there's a I think new load balancer that is written in Go entirely, and one of the benefits it says is that it does these things automatically. So it will not crash everything. It will gracefully try to handle the load.
So what would it do if it gets, for example, if it can't handle 10,000 requests, then what would it do in that case?
It will, so instead of immediately switching over, it will exponentially back off. So it you crash the first one, switch to the second,
Yeah.
crash the second one. Then instead of
Yeah.
immediately switching to the third one, it will wait for some time. Then if it crashes the third one, it will wait for double the amount of time. Then double the amount of time.
Okay, what is waiting doing for us?
So you're hoping if it is a peak, like if it is a surge, like a temporary peak of users or something, then it subsides in the meanwhile. So it does not. So essentially, you don't crash everything, in series.
Okay, but like from what I mean, at least from what I know is that like now we are things are built to keep retrying, right? So in that case, wouldn't waiting just make it worse, where everything is there are more requests coming in, but everything before that is also trying to retry their requests and everything, right?
No,
So doesn't that make
requests
the problem even worse?
wouldn't requests have timeout. So if it is exponential back off, eventually that back off will be larger than the timeout for this request, and you will see all these requests going down. And retries also have a particular uh, limit to retries.
Limit. Okay, that's fair. Okay. How is consistency ensured if Patroni does backfill or application? Again, that's a choice that you have to make, right? So there's many options where you can do synchronous application or asynchronous application and things like that. So it's synchronous, you get your consistency at the cost of there being a delay to reply and to commit the transaction and things like that. But with asynchronous, your latency is reduced, but again, your consistency is the triangle, right? So it's a trade-off, so you have to decide what you have to make. Um so as Patroni uses HCD for state consensus between the other database nodes, HC proxy and keep alive do some external system. It
No, this
is
was
built in.
answered. This was answered.
I'm sorry.
You answered this for like Karthik also
Okay.
asked something similar.
Okay,
Yeah.
fair enough. So this is one thing, and now it's smaller things where it's okay, yeah. So for DNS, right? Again, if mass complete, so if just go back to the thing. So for DNS, right? Because this service handles its own DNS. So if the entire service goes down, well, no one can reach the service because there's no DNS resolution, right? So there's one extra node that picks up that owns the WIP. There's a DNS WIP, right? So uh, whichever DNS forwarder or whatever you're using, you have to give them the WIP, right? Hey, if you get a request for any of these servers, play any of these domains, because MAAS manages its own domain, right? So if you get any request for these domains, please send it to this WIP, right? So so if both controllers go down, we still have DNS resolution up, so that even if OS deploys and other things that MAAS managers don't work, at least whatever is currently existing, those services can still be accessed, right? So you need to have a node that picks that DNS up when MAAS is completely down, right? So that is essentially what this DNS HA is talking about, where MAAS internally uses bind, Berkeley Internet naming. I forgot the thing, but bind is a very famous and very, very, very core DNS utility. So it uses bind internally. So essentially, there's one node which is copying, as a cron job, is constantly copying that bind information or bind bits from the controllers into itself and storing all those records with itself, so that in case there is a failure, at least till whatever last time it backed up the records, it has that information, right? And obviously keep alive D is used for those 3 nodes, so that whoever is up can take the DNS request, can answer the DNS request. So that is the implementation of that. Any questions around the DNS HA stuff?
What is the interval between that for that cron job?
I mean, it can be anything you set. Like, what's the point you're trying to make?
It's not a point. I'm just asking. What is
it can be anything, right? Like this
time for this?
I mean, there's an example, right? So you can literally do whatever you want, right? So yeah.
No. I
understand.
Okay, fine. Let me rephrase it. What was the default interval for this cron job, or what did you keep while you were experimenting?
I mean, you can do 15 minutes, every 15 minutes. Right. Again, it also depends on how much load your system has, right? If it's a fairly if there's not a lot of systems that you're managing and things like that, you can do it probably every 5 minutes or every minute and stuff like that as well, right? But if you're managing tons and tons of systems, then obviously it takes time and things like that. So you can reduce the frequency. So it depends on how many systems you're managing.
All right.
So and then for MAAS, because all the other services in blue that you see, this is blue, right? So all these other services in blue that you see, those in MAAS internally manages the HA for that. That is opaque to me. I did not go through the code base on GitHub, but they use HA proxy internally to do things, and they have their own HA setup for these services, where if one controller goes down, the other one automatically picks up, and things like that. So that is the MAAS thing. Then so first theme was automatic failovers, and now the second theme is automated backups. This is relatively very simple for a small implementation. This was PG dump is the most commonly used thing. PostgreSQL has it inbuilt, and there's other things like PG backrest and other things as well. But PG dump is very easy to use for simple things. So there's a cron job that again runs this database backup, where it creates that dump using PG dump, compresses the dump, and stores it at a safe location like a network attached storage or some NFS or something like that, right? And as we talked about before, for restoration, in case a node goes down or something, you can just take it down, restore that node to wherever the last backup was, using Postgres itself, and then let Patroni tell Postgres to replicate it from the other nodes, right? So that is how you can use your backup files, backup dumps. And then obviously you need to back up your OS images as well. It's again just a batch script that takes the OS images, compresses them, and stores them. That's that for me. If you want to look into MAAS or anything like that, you can look that up. Other technologies, you can just find the documentation. And that's that for me. Any questions that anyone has? Oh wow, that ended actually exactly on time in an hour. That's and we started a little late as well. So nice. Any questions, anyone? Okay. Thank you. I can. Okay. Okay, I think we can stop recording then. Thank you, Alan. Appreciate you. Merry Christmas and a Happy New Year to everyone, by the way. Ankush, did we stop recording?